Hi, everybody. Check out that. That was a memento from Peru. I've just been traveling throughout South America for the last few weeks. So it's been a whale of fun. Okay, let me just bring up my slideshow and hopefully you'll all be able to see that. Now you can see that the very first slide is do not adjust your set. In fact, before I start, welcome to office hours. Good evening and welcome to office hours. This is number 7 for me, I think, the 7th DBA office hours. I was telling some people actually in my tour of South America that we've done over nearly, I think, 100 hours now of office hours sessions. 100 hours. That's 100 hours of free Q&A. So hopefully you're getting plenty of value from it. I certainly love giving them, as you can probably tell. And just it's a great way of exposing some of the experts who know a lot more than me in the organization to the general community. I've put do not adjust your set there because a couple of reasons. One is if the sound is terrible, that's not necessarily my microphone. It's more likely the fact that I've got a head cold. And my apologies for not doing the office hours last week. I basically lost my voice. When you sit on a death tube, as they call it, or a plane from South America back to Australia, all it needs is one person on that plane to cough, and next thing you know, we're all sick as dogs. And the other reason is I put do not adjust your set is you'll see that if I look at my other screen here, the slide layout is all pitched across down to the left. That's really such that because we record these sessions and then we plonk them on YouTube for people who can't make the sessions and if people want to see them and review some of the highlights later, what I've done is I've moved some of the content on the slides down to the left such that when I superimpose my enormous head onto the YouTube videos, we're not going to lose content. I had some feedback from some previous office hours sessions, people saying that when we superimposed the video together, some of the code snippets were no longer visible. And so people got frustrated. So that's what that's for. First of all, before we get into the questions, let's talk about some bits and pieces, some things that I thought I'd bring you up to date with. Number one is the tour update. As I mentioned, I spent just under 3 weeks, I think, or maybe 2.5 weeks in South America, going to part of the Oracle Developer Community Latin America, that's a mouthful, tour. It's 12 cities, 6 in the south and 6 in the north. It's still going. For those of you that are active on Twitter, get out there, you'll see people like Tim Hall, Jared Wenzel. They're currently still on the tour, or they've taken up the tour where others like myself have left off. I did 5 cities, starting in Chile, going through Brazil, Uruguay, Buenos Aires, and Peru. Fantastic events, fantastic country. Certainly, without trying to single out anyone, if you ever want some guidance on how to run a fantastic event, get in touch with Alex from Brazil, Edelweiss and Nelson from Uruguay, and Miguel from Peru. Those 3 in particular were just breathtakingly efficiently run events. Peru was a highlight for me in the sense that they had dynamic translation, real-time translation. So I'll be honest, my Spanish skills are pretty much capped out at, I did not speak Spanish, no habla español. But other than that, we had translators there, which was really good because it made for really interesting networking with the attendees and the like. So if you're a speaker on the call, please get involved in their Latin American user groups. If you're a member of the user groups in Latin America, thanks very much. It was a fantastic event. Second bits and pieces, a little bit of bad news. And I've been pushing or touting the last few office hours how good 18CXC is going to be and that it would be out when we did the Windows release port. This was a post made by Gerald, who's a product manager for XC just recently. And if you zoom in now in the line in blue, you can see we've had to delay it until around about open world. Now, I wanted to mention this because when this came out, there was some flutter on Twitter, and I think there was an article in the Register and a few other places. They're saying, well, the reason they've deferred XC is because it's a free product and Oracle don't like giving away free products, and so that's why they've delayed it. They don't have no interest in it, etc. I've spoken to Gerald, and what's more, I've been one of the beta testers for 18CXC. I've been playing with the release candidates, and I can tell you that's simply not true. One of the things that I've been actually pleased with, not that I want to delay software, but one of the things when I was playing with it was the ease of use installation was reasonably good. And we want better than that. We want better than reasonably good. We want it to be sort of a one-liner, just go. And being a DBA where I like to try break things, when I was using the installer in terms of practicing it, I was trying to come up with scenarios that might be slightly out of the ordinary. I was messing around with host names and IP addresses and whether networks were turned on and what storage was available, doing my best to confuse the installer. And a number of us in the organization were doing this kind of what we call destructive testing. So I'm pleased that we've actually decided to pause XC for that little bit longer to make the experience as seamless and as smooth as possible for people when that finally comes out. So it's a bit of a sad news that it'll be out a little bit later on this year, as opposed to we sort of had promised, I think, July and August. But I think we'll actually all be the better for it. It'll just be a really nice one-stop shop, free database. I won't spend any more time on why I think it's going to be such a game changer. Maybe I'll save that for next office hours, but I'm pretty pumped about XC. But for every bit of bad news, there's some good news as well. And the good news is pretty much, I think, yesterday, maybe early this morning, my time, the full enterprise edition of 18C for Windows is now available on premise. The first thing I did today was obviously download it and install it. I'll post some videos in the next couple of days of my attempts at installing it. They seem to go fairly smoothly. Funnily enough, when I was preparing for this office hours session, of course, all my demos are running in 12.2. And I thought, let's just download XC and let rip. So let's download X18C and let rip, which of course created some problems for my demos because now I've got just another version of Oracle software running on this poor machine. But either way, it all went fairly smoothly for me. And I'll put some videos up in the next couple of days. So that's my bits and pieces. What are the questions? What are the questions that have come in from the good folks in the community over the past few weeks to help out this office hours session? So let me just have a quick look at them. The first one I'll deal right at the end. And because it's more of a generic question and it comes in at every single user group meeting, on forums, on Twitter, on Facebook, what is the future of the database administrator? And given that this is the DBA office hours sessions, I figured this was a good forum to talk about it. The reason also I'm deferring it right to the end is if you want to put your thoughts in the chat line, feel free to compose some thoughts and throw them in there. And we'll, what I'll do is I could probably turn that into a blog post if you're happy to have your thoughts sort of published and just on people's thoughts. But I'll give you my thoughts toward the end of the session. Having said that, I'll keep an eye on my phone this time. So I know every session I always end up running over time or out of time. The questions that came in were, what about shutting the database? Should we be shutting the database? How often should we be shutting the database, etc.? The next question was continuous query notification versus database change notification. It's funny, someone on Twitter the other day was having a sort of a humorous rant about the number of three-letter acronyms that come out of the Oracle organization, and perhaps we've actually run out of the permutations. And so yeah, CQN, DCN, let's talk about what they are and how they differ. Next one was a couple of ones which are probably we've touched on already in office hours sessions in terms of doing data maintenance and structural maintenance without impacting the users. So one was, how do I replace a table that currently has a varchar2 primary key that contains numeric data? How do I suppose, correct that into having a numeric primary key? We'll talk about that. And the other one was, how do I move from a 16K table space to an 8K table space? Once again, the keywords there being online with minimal outage. And we'll talk about them. Obviously, those who have been on previous office hours sessions will have a few hints, a few inclinations as to which way we'll be tackling them. But both of those questions came in with regard to 12.2. So we have a few more flexible options there in terms of tackling the issue. Then we had how to prevent archive log removal for flashback database. People who have used flashback database or are familiar with it will know that we actually have a thing that isn't archive logs. They're actually called flashback logs. So how do archive logs relate to flashback database? We'll cover that as well. And the last one, which is interesting, I've seen this question on about 3 or 4 different office hours list of pending questions. As recently as there was one on the SmartDB office hours a couple of nights ago about what is inherent privileges. It's a new sort of concept that came in Oracle 12. Interestingly, without trying to be critical of anyone else who runs the office hours questions, the question that came in, they said, I sat on a different office hours, they explained what it was, but I didn't really understand the explanation. So can you come up with a simple example? So that's what I'll do. I won't go into great details about explaining the nuts and bolts of it. I'll just present a nice little simple example which explains why it was needed and what problems it solves. So that's what we're going to do. Let's jump straight into it. And we'll talk about first database shutdown. The question came in about how often should I shut down? Is there an issue with shutting down? When should I shut down? When should I not shut down? So I thought what I'd do is I'd outline my idea, my rules and guidelines for the means and frequency that I work to when it comes to shutting down my database down. So my rules and guidelines pretty much fall into two things. Number one is don't shut down your database. Now, the second rule I have is don't ever shut down your database. It's as simple as that for me. I would never ever shut down a database unless I'm actually forced to. And I'm going to try and justify to you why that is the case. Shutting down a database, I think, is a relic of a bygone era when, databases had certain issues in terms of when they could be backed up or what kind of maintenance could be occurred. But ultimately, for me, if I can never, ever shut down a database, I never, ever will. It's funny, on the Oracle L list recently, someone were doing a poll as to show me your most highest uptime database. And I was thrilled to see that there were some databases in that literally hadn't been bounced for a number of years. And interestingly, some of them are running on Windows as well. So those people that say, Oracle only runs on Linux or whatever, that was proven false. Almost any platform, hopefully you should be able to run your databases and never, ever shut them down. Already you can probably get an idea that there's a bit of a warning going on here that I'm going to have a bit of a rant now. And that's true. I'm going to basically have a bit of an explanation as to why I think you should never take outages. And so this is my mantra. Stop taking outages. Not just database bounces, but across the board, right? I don't think we should be taking outages ever on our databases if we can absolutely avoid it. And one of the reasons I say this is for many, many years I've worked for various clients, and I often think that outages are for lack of a better term, the lazy way out or the easy way out. It's amazing how many times when some data maintenance or some structural maintenance has to occur, and yes, it might, before 12.2 in particular, might require more moving parts, more steps to actually enact that maintenance without taking an outage. And so we just go, well, tell you what, we'll wait till midnight and we'll have a 4-hour downtime and we'll just deal with that. I think that's a really lazy way of doing it. And there's a cost to doing that, which we'll explore shortly. But the thing, I think really, it's not about technical reasons, it's a mindset reason. If your mindset is focused on never ever take an outage unless the software makes me, then I think you're actually doing a better service. But let's work on a couple of reasons. So let's talk about the technical reasons first, why I think you should always try and avoid taking an outage. There's an inherent cost to restarting your database. A database is not a laptop. It's not a desktop PC. It's something far more significant and something far more valuable in your organization. So, we've all seen the famous YouTube clips of, have you tried turning it off and on again? That doesn't really apply or shouldn't apply to the bouncing of databases. Every time you shut down your database, and this is a little graphic here to add some humor to tonight's session, effectively you smoke your database. You smoke all those important things that are running inside your database right now. What is a database that Oracle has that stands it above all the others generally? And it's pretty simple, really. It's all the complexity in terms of managing the data. Let's face it, a text file is a database. The problem is it struggles with concurrency and struggles with format. All the complexity that makes Oracle awesome, and also, let's face it, pretty expensive, is a key thing, right? That is why you spend a lot of money on Oracle, for all that benefit of complexity, of concurrency and scalability and performance. And all those things are by and large implemented in the memory structures. Now, when you shut your database, what are you doing? You're throwing all those memory structures away. So what you're really doing is throwing away the money that you're spending. It's your investment in that complexity of memory structures that make the database so cool and so awesome. You're just throwing that away every time you bounce the database. Because what you have to do when the database comes back again is reinstantiate those memory areas. And that's not cheap. Now, I thought we'd do a little demonstration here to prove that. So let's do a new share, jump into our SQL+ window. So hopefully we can all see that. Now, what was the name of my script? I've forgotten already. I think it was parsing. So what I'm going to do here is I'm going to create a table called T. It's got a primary key, single column. It's a very, very simple table. It's organization index, so we can do very, very fast, efficient primary key probes into this table. The cost of querying it, the actual activity of querying it, will be incredibly cheap. There's 10,000 rows in there. This is one of the demos that you can find on every website that talks about using bind variables. So this is what I call a good example. We're using bind variables here. I'm doing 10,000 iterations of a very simple select from T, where X equals the primary key. And you can see that on this machine, I can do 10,000 simple queries in 0.1 of a second. So that's very snappy. And then the second part of a typical bind variable demonstration would be, okay, let's look at the worst case scenario. And here I'm repeating the exact same set of queries, 10,000 queries, but you can see on line 5, I'm actually concatenating the literal value of I, such that I'm actually going to present 10,000 individually different queries to the database. That's a parsing overhead. I run that, and obviously you can see it's inherently slower. That took 4.1 seconds. Now, the reason I'm showing that is actually when you bounce the database, every query that is presented after that has to be reparsed. It's a hard parse. That's the CPU cost you're paying every time you bounce the database. Now, these are very simple queries, and I presented it like this because a common rebuttal nowadays, now that servers are so fast and memory is so fast, is, well, yes, that is slower than your first demo. The first demo was 10,000 queries in 0.1 of a second. This is 10,000 queries in 4 seconds. But really, that's still 2,500 queries per second. That's not such a big deal, is it? I mean, who cares? That surely is not something that's going to encourage me or stop me from bouncing my database, or in this case, using bind variables. Parsing doesn't seem such a big deal. This is true when the queries are trivial. But of course, how many of us have trivial queries in our applications? The reality is some of our queries are much more complicated. So let's make it a bit more realistic. Let's say I've just bounced my database, and now I'm going to do some queries like this. I've got a 2-table join here, and those 2 objects in there are actually database views. I've just picked DBA all objects and DBA segments just because I know they're fairly complicated views. These are synonymous with the kind of views and definitions of objects and queries you would probably have in your applications rather than just single row selects. Now, I'm using DBMS SQL here because I want to take out the actual cost of running the queries. You can see I'm just doing a parse command on line 6 there. I'm not even running these queries. I'm simply asking the database to parse it. This is the kind of parsing that would happen for every single query once you bounce your database. Let's give it a go. I'm doing 100 iterations. You can see on line number 5, 100 iterations of parsing. I get to take a drink now because I know it's going to take a while. 15 seconds. Now, that's only 100 queries. So you can only parse, on this machine, 6 queries per second once those queries actually become quite complicated. Parsing is hard work. It's very hard to work out how to run a query in the best way. Sometimes the parsing cost is far more than the actual execution cost. There's a more realistic example of the kind of hurt you're going to suffer when you actually bounce your database and have to reparse your applications. Now, out of that 15 seconds, let's have a look at how much of it was actually just hardcore CPU times. Actually, all of it. So it's not like we were doing I/O or we were accessing disk or we were blocked on locks. We actually absolutely flatlined our machine because parsing is a very, very CPU intensive activity. And believe it or not, that is the best case scenario because I've only got one user here doing this parsing. In reality, when you bounce the database, the moment all your applications fire up again, what happens? We've got dozens or hundreds of sessions all competing, all parsing and all competing for memory structures. it won't be 100% CPU in that case, because heaps of them will be blocked and they'll be contending with each other. So you have a lot of expensive CPU and lots of people not getting work done. So the cost of a restart can be huge for complicated applications. Let's flick back to the slides. So as I said, it's not cheap. And funnily enough, as I said, the demo there is probably the best case scenario because it's only one user. Realistically, it's obviously many users that make things even worse. But guess what? It can actually be far worse than even that. It can be really not cheap. What do I mean by that? Well, as I mentioned, we have to re-instantiate all these memory areas. Now, those memory areas are the buffer cache. They'll be re-instantiated by the cost of I/O. Now, putting stuff into the buffer cache while incurring some CPU cost is probably negligible compared to the disk cost of actually reading it back in. Obviously, that would have been avoided if you hadn't restarted, but once you restart, the actual CPU cost is low compared to the disk cost of getting that data back in. So it will be populated as required. The shared pool, as we saw, it's expensive to populate, something to be careful of. The read log buffer, large pool, other shared memory components, they're generally going to be reinstantiated on an as required basis. So at that point, yes, we've seen there's a big CPU cost, but maybe we're still thinking, that's not so bad. But there's one other area that if you're using it also needs to be repopulated, and that is the in-memory column store. Now, that's totally different. When I populate information into the buffer cache, I'm reading blocks off disk, and I'm putting those blocks into pretty much the same structure in memory. It's almost a one-for-one. Read a block, put it in memory. Read a block, put it in memory. The in-memory column store is totally different. As you've seen from probably many presentations on in-memory, it is a compressed, rejigged, reformatted, transposed, deduplicated representation of the data that was originally in blocks. It's now in a column format. Doing all that work doesn't come for free. In fact, back in the early days, the very first iterations of Oracle 12, when you actually restarted the database, you would often see these W processes, as you can see on screen there, consuming the entire machine because it was working so hard to repopulate the memory store. In fact, to the extent that we introduced a parameter called in-memory max populate servers, which defaults to only half the available CPUs because we recognize the fact that it's expensive to repopulate that in-memory store. It costs a lot of CPU, and we didn't want to actually destroy your server in doing so. So we capped it at basically only half the available resources. So you've got to work really hard. In fact, if you're on 12.2, you want to be using something called in-memory fast start to avoid this. What that does is at regular intervals, it'll dump the in-memory store down to a blob on disk, such that when you do have to restart, which hopefully is as little as possible, we can read that blob structure back into the in-memory area without having to recompress and retranspose all that data from the buffer cache and the database data files. In fact, for those, just as a sidebar, you can see that's how you enable it. You do dbms in-memory admin fast start enable, you give it a table space name, and then what happens is you can see we just store a secure file blob, which is literally a binary representation of the in-memory store at regular intervals, such that we can read it back in on a restart. But as you can see, if you got in-memory, the restart costs could be huge for you, as well as all that library cache and share pool and buffer cache repopulation. It's a bad idea to restart your databases. What's this picture represent? To finish off this question, this is the Centennial light bulb. It's in a fire station somewhere in the US. It's the classic representation of how a database should be treated. This is the longest running light bulb in the world. It's been turned off once since 1905. And when they realized that the light was still going, they've now put it on a permanent non-switched circuit. It still burns today. It's the world's longest running light bulb. Keep that picture in mind and that light bulb in mind when you're actually dealing with your databases. If you can, never shut them down. In fact, I'll say one last thing before I get into question 2. The other thing that's probably critical here is, just checking the chat line. Someone said, what about suspend database running in my virtual machine and my laptop? Better to shut it down. I think if you were, I think most virtual machines you can actually suspend at the virtual machine layer as well. But I should say, yes, I'm restricting myself here to actual enterprise applications or things running in your workplace. On your laptop, you can do whatever you want. That's exactly what I do as well. In fact, I don't even shut my databases down when I shut my laptop down. I just literally turn the laptop off because it's an Oracle database. It's rock solid. It's going to recover from the ready logs, instance recovery, no problems. One last thing on shutdown, and let me go back to my lovely light bulb, is also, I think, not shutting your database down improves your reputation with your employers and your customers. Because having said all this, having pontificated now for several minutes about shutdown and restart, one thing that is important is you're going to have to do it anyway at some stage. The reality is, in a perfect world, you would never shut down. And that's our aim inside Oracle. We try to get every upgrade to be online nowadays. We try to get all that patching to be online, but we're not there yet. So there's going to be some patching. There's going to be some upgrades that you have to have outages on. So it's bad enough that you're limiting your customers' ability to use your applications in that sense because it's forced upon them. So, my view is, have some real pride in what you do as a DBA. Every time you can avoid an outage, you've delivered more benefits for your customer. That's the last I'll say on that. CQN, DCUN, continuous query notification and database change notification. What is it? What are they? Well, it's the technical equivalent of having children in the backseat of your car. Because whenever you go on a drive somewhere, what do your kids do? Are we there yet? Are we there yet? Are we there yet? They want some sort of feedback, but they want you to push it to them. They don't have to, ideally they wouldn't ask the question, but after all, they get bored and they're not seeing anything happening and they say, how much longer, how much longer? At least that's what my kids do. It's the equivalent in databases. We have heaps of applications that effectively want to show, is there new data? And so they often are written like, is there new data? Is there new data? Is there new data? Is there new data? They keep polling the database aggressively such that one day they'll be able to show you something on your phone like this. I've put your flight has been delayed because that's what happened to me in South America on a couple of times. But this is the kind of concept that CQN and DCN were designed to help solve. The idea that maybe rather than you as an application having to continually come back and see if data has changed, the database could actually let you know if something has changed. Now, DCN, database change notification, was our first cut at this. And that was a pretty simple concept. What you would do is, as a developer, you would register interest in the database with an object. You would say, I want to know if the scott.emp table changes, as in someone puts some rows in or removes or updates some rows, etc. And what would happen is you would be then sent a message, and it could be through OCI. So if you could be using .NET in the thick client or Java thick client, you would be actually sent asynchronously a message saying, by the way, something has happened to the scott.emp table. And that's very useful, don't get me wrong, but it really was our first cut. I think it came in maybe 10.2, because obviously if I have, say, a table of customers, I probably as an application maybe only want to register interest if the customer that's currently on screen has changed its details, not if any other customer. So having it at the object level is perhaps a bit too coarse. So that's where CQN came along, continuous query notification. That came in at 11.1, I think. The concept is identical. Let me know when something has changed. But the nice thing was with CQN, it is the ability to say, only send me a notification, only let me know if the output of a query that I provide to you actually changes. That's obviously far more granular and far more effective and useful than something just at the database change level. So at a simplest level answering the question, that's the difference between database change notification and continuous query notification. One is a coarse operation at the object level. The other one is a much more granular and perhaps effective mechanism at a query level. But just to show that the actual two things are not mutually exclusive, there are some queries in which we can't do that kind of notification, and so we fall back to object notification. And I just thought I'd show you a little demo of how that actually works. And obviously, the reason I thought I'd show you a demo, another reason, is a lot of people have never seen continuous query notification. So let's have a look at it. I think it was CQN. So I'm going to create a table called CQN. It's just a copy of all objects, and I've got an index on there. And I'm going to create a table here called notify log. And what that is every time we get sent a message saying, oh, something has changed, we're going to write a message to that log. How do we do it? We have a special procedure. It's called mcdonald.callback, and it takes a particular kind of parameter as an argument. It's a particular data type. And we're going to do nothing. Inside that information is not, let me start again. Inside that parameter, ntfnds, is all sorts of information about the details of the notification message. But for us, we're just going to simply log a row in that notify log saying, yep, something came to us. This is the rather obtuse code that you can use, but it's straight out of the documentation to actually register a query. So what we can see there is in line 6, I'm saying create some information. I'm going to call a routine called the callback routine every time I get a notification on my query. So that's QoS_query. When I get a change to a query result, I want to receive a notification. Then how do I actually register a query? I do it by using a ref cursor. So on line 12, you can see I'm saying opening a ref cursor for the following query. It's my own query plus one extra column. That is the query notification query ID. The reason I do this is if I've registered interest in several queries, that ID lets me identify which particular query I've received a message for. But this is a very simple query. Select owner object name, object type from my table CQN, where the owner equals Scott. So this is an example of I'm only interested in the rows where the owner is Scott, not just in any change to the table, only the ones where the row is Scott. So let's see how it works. I select the sys timestamp so we can see roughly how long it's taken to get a notification. I delete a row from my CQN table. That should be enough to actually fire a notification. I commit the row, and you can see there's a row in the notify log table. And if we look at the timestamps, it actually came within about a second. Okay, so what have we got? 14, yeah, within about a second. Under the covers, what's happening is we're using some AQ infrastructure, the database is, to fire messages off and to run some callback routines. But as you can see, CQN's pretty cool. You register interest with a query. When the result of that query would change as a result of DML, you get sent a message and you can react accordingly. I'm doing it all in PL SQL, but it could be a Java application, it could be .NET, it could be anything that actually up in the middle tier as well. Just to show you what happens when you have a query that's sufficiently complex that we can't do query notification. Here's the same copy of the table, the same indexes, the same notify log table, the same procedure. Now I'm going to try a more complicated query. And this is what happens, you can see on line 14. My query of interest is I want to be notified when the number of rows for the rows that have owner equals Scott change. If I run that, I get an error. What it's telling me is I can't guarantee that I can give you a query notification that's always correct. And that's what the QoS query on line 8 is saying is I want to guarantee that I'll only get notified when that query changes. Count star is an aggregate, and we can't implement that as of 12.2. We have to go to, you can see line 8, what we call the best effort, which means the database will try to satisfy that, but if not, it'll fall back to just change notification. To prove that, I've got 36 rows at the moment in the table for Scott. I delete a row and I insert a row, which obviously simply keeps the count the same, but that query is too complicated, so we still got a notification. That's what we call best effort mode. We didn't guarantee you that we could satisfy that only send a notification if that query changed. But anyway, that's just a quick demo of query-based notification, just to show you how it works. I should say though, that is a really useful feature, but keep the mindset that it's about getting notifications, right? This is a really useful feature if you need to be pushed information when data is, say, rarely changing. You want to be pushed information such that you can react to it. If you just want to repeatedly avoid polling data, probably a better way is using result cache. Now, most people are familiar with the server-side result cache. We use that all the time. It's very popular. If you ever use Apex, we use it everywhere in Apex. But there's a partnering technology called the client result cache. And that works pretty similarly, except on your client application, when you run SQL, what will happen is you can repeatedly run the same SQLs, throwing them at the database, but it will only visit the database at regular intervals when it thinks the client-side information is stale. How do we control that? I'm just checking my chat line. Someone said, aren't they deprecated in 18C? Not to my knowledge, but I will check that for you. That's an interesting question. I didn't think they were, but I'll check. When you say deprecated, are you talking the result cache, or are you talking about query notification? Throw that in the chat line. If it's query notification, if that is the case, I was unaware. I'll check that out for you, and if it is, I will blog post about it. Thanks for letting me know that. I'll check it out. So if you are just repeatedly polling information and you want to avoid the cost of polling, a better option than relying on notification would be the result caching at the client level. And what that'll do is you can see these are the default values for me. The top one's the default. I've set the bottom one to 4 megabytes. Once they're both non-zero, as I repeatedly poll the database, what will happen is every 3 seconds, or for up to 3 seconds, I'll simply avoid the trip to the database. And therefore, I'm effectively nominating how stale I'm allowing my client data to get. So that's a really simple way of having something that currently aggressively polls and doing no application changes, and just having it be far less aggressive and the application is unaware. So that's question 2. Geez, the time goes so fast. Well, these hopefully will be a good kicker. If I have to skip some, I will, because I want to get around to the DBA career discussion. Converting a varchar2 primary key to a numeric one, doing it online. As I said, we covered this kind of concept in the last session, so I'm just going to fly through it because there's a couple of subtle differences to some of the stuff we saw in the last office hours session. So I thought we'd just show workarounds for some things when you get into difficulty. So let's fire it up and we'll go through this one fairly quickly. Office hours, primary key. Convert. So here's my table called T. It's simply a copy of all objects, and you can see I've deliberately made the primary key column, PK, just a string version of the object ID. So it's got numeric data, but it's being stored as a varchar2. There's the primary key. I'm going to create my redef definition table to use in DBMS redefinition. I'm going to call it tinterim, but it's got the primary key column just as object ID. So it's going to be numeric. So this is how I'm going to convert from one to another. There's my table called T. As you can see, it's got primary key. It's a varchar240. And here's my table called tinterim. It's the exact same structure, except the first column is a numeric. So those who were attending last month's session will know that we can use DBMS redefinition to do this. The reason I included it in this month's session as well is to show some of the subtleties that might become involved. So let's do our first cut. First cut is let's just try to do a redefinition, and we get an error. And the first thing we find there is by default, DBMS redefinition has to have exact match for match on columns. But we saw last month we can get around that using column maps. So I've got there in line 3 through to line 8, I'm using a list of columns and the appropriate expression to map the varchar2 to numeric as I go. That you thought would have worked, but it doesn't. You get this very strange error saying materialized view does not include all the primary key columns. If you're doing a column mapping if you're doing a modification of the primary key using the column mapping, then DBMS redefinition has a few dramas. So if you have a DBMS redefinition fail in the middle of a redefinition, you have to abort it. So we just do the abort, and that puts things back in place as if we'd never run it. And this is how we solve it. Even though we have a primary key, using line 15 there, use the row IDs to do the modification as opposed to the primary key, then it runs fine. That's why I wanted to show it in this month's session, just to show you that there are different permutations of DBMS redefinition that you might need to use for certain scenarios. And I can add the primary key back in, finish the redefinition, and we're done. And there we have our new table called T. It's got a numeric primary key, and we've copied all the data over with minimal outage. So hopefully that, if you're on the call, that answers your question. That's how you can do your conversion with minimal downtime. As I said, we covered most of that last session, but those nuances in terms of how to use DBMS redefinition were worth talking about again. Question 4, moving to a new block size. Now, let me talk about multiple block sizes first. Now, there's a lot of rubbish out there. I was going to say a lot of crap, but I'll edit it out of the YouTube video. There's a lot of rubbish out there about why multiple block sizes are a really good thing. And most of them are historical and they're pretty much wrong. The only reason we invented multiple block sizes back in, I think, Oracle 8.0 was we introduced a feature called transportable table space. And obviously, if you were transporting table spaces between multiple databases that had different block sizes, a single database had to be able to support multiple block sizes. That was the motivation. Yet people just lost their minds when it came in. They said, "Oh, I know why we're implementing it, because we occasionally get these kind of errors when we're trying to build indexes." Now, I can tell you, multiple block sizes was not designed to solve this. Good database design was designed to solve this, because if you got indexes that are longer than 6 kilobytes in length for a key, I got to tell you, that's the wrong key. That's the wrong column. Or people said, "Oh, if I've got massive block sizes, then my indexes will be shallower because indexes are implemented as a B tree. So if I can cram more data into the branch blocks, my indexes will be flatter and less shallow." That's also pretty much a nonsense. You can put, I think it's several billion rows, depending on the size of the key, literally several billion rows into a B tree index of level 3. To jump to level 4, suddenly you're up to the 64, 100 billion row kind of mark. The reality is, if you got that much data, why do you have index access to that data? It's pretty rare. Most databases in the multi-billion row range, I say most, not all, are generally data warehouses. And it's extremely rare you'd be relying on heavy index access to them anyway. If you are, you maybe got some physical design issues you want to, maybe want to tackle. It's extremely rare. And the other one is, maybe I want less space in my data warehouse because every block has a block header and some block overhead. Once again, you're probably looking at reclaiming just a smattering of bytes per block. Even if you've got millions or trillions of blocks, you've already, if you're into the petabyte range, well, yes, you might save a few gigabytes here and there, but let's face it, you're still in the petabyte range. A lot of those arguments just don't hold water, even though people have blogged extensively about them in the past. Probably the best authority of this, if you search on the Google sphere for a guy named Roger McNichol, he's a very intelligent guy inside the Oracle organization, deals with a lot of Exadata and storage technologies and knows this stuff backwards. He's got a great blog post which simply says, pretty much you should stick with 8K. It's tried and true. It works absolutely fine, unless there are particular boundary cases that you need to worry about. And some of the examples might be there is you might have, every row might be, say, 9K. Just that little bit larger than 8K, and it so happens that you need to access the rightmost columns. Apologies, that was my phone making that noise. That's my phone telling me that I've only got 15 minutes left. Nothing worse than that. So there are some very small boundary cases that you might want to consider a larger or different block size, but the reality is 8K is pretty much going to run sweet for you. But this is not being critical of the person that posed the question. They were saying, I want to get all my systems from back to one block size. They had a 16K table space. They'd like to move all the data to 8K. So let's see how I would go about doing that. Oops. I still had a bit more. Block size. So I've set up some examples here just to show on my little database here as to how I would do it. As you can see, there's my list of table spaces. I'm using a stock standard 8K block size, except I've created a new table space called Demo 16K, which has a 16K block size. Just for the people that aren't familiar with multiple block sizes, if you're going to have any particular block size in use, you have to have a buffer cache allowance for that. So I've set my 16K block cache size here to 64 meg just to hold some data. This is the kind of activity. So this is to help our person that made the question. He's got all these objects in a 16K table space. How do I move them to an 8K table space? You have to do it generally on an object by object basis and look at some mechanisms as to how you would identify those particular objects. So here's an example of, I'm going to go the opposite here. I'm going to look at moving objects from my users table space into this 16K one, but it's really just the same process. I'm changing the block size. So you can go look at DBA segments. And as you can see, I've got dozens and dozens of them. But what you want to do is tackle them on a object type by object type basis. So let's look at some examples of how you would tackle these things. So here's the most simple example. If I have a table, which is just a stock standard heap table, I've got some rows in it, and I've got a primary key and some indexes on it. Those ones, if you're on 12.2, and this our questioner came in, it said 12.2, really easy. As I can see, all the segments there from that table are in the users table space, the table itself and the two indexes I've created. My first cut of this is alter table, moved it to the new table space, online, works fine, no interruption to service. That seems really, really cool, except by default, what I'm doing is moving just the table. My indexes stayed valid, but they didn't get moved. So that in itself is a good thing. I could move a table without an interruption to service, but the indexes didn't come along with me. If I want to move everything, it's just a slight alteration to the syntax. You add the update indexes clause, nominate the indexes and their new table space, and then you can see the whole lot got moved over. So I'm moving from 8 to 16 here, but the same logic applies to move back. So the vast majority of your tables in 12.2 is just a one-liner. Grab those tables and off they go. What about more complicated examples? So here I have, for example, a table that has a lob column in it. How do I deal with that? Because when I create a lob column, I could actually create multiple segments, one for the table and then one for the lob index and one for the lob segment itself. All those things might actually sit in the table spaces of question. I've tried to do an alter table move here, and as you can see by default, it's similar to the indexes. The table got moved, but my two lob segments are still sitting in the user's table space. But once again, in 12.2, it is just a one-line command. You just need to augment the syntax a little bit. I'm moving the table, and I'm also moving the lob using a store as syntax to move that to the table space as well. And as you can see now, the lob segments have also gone to the new table space. So tables with clobs, etc., can all be moved pretty simply. Here's where things get a bit more interesting. Here I have a table which is partitioned and subpartitioned. So all of those things will be in the user's table space. Let's try do an alter table move. You can't do it. It says you can't do an online table move for that table. Let's try move just one of the partitions. I can't move a partition if it contains subpartitions. So let's now dig right down into a subpartition by subpartition at a time basis. And I have a problem. And the reason for that is all the partitions of a table must sit in a common table space size. Sorry, a common block size, I should say. Now, that makes a problem because I couldn't move the entire table, but I can't tackle it partition by partition at a time either. This is an example of where I'd probably get into using DBMS redefinition, as we saw in the previous demo. But just to sort of finish this off, as you can see, I can generally move the vast majority of my objects with one-line commands, just on a table-by-table basis. And for those special cases like partition tables, etc., I'd have to look at something a little bit more convoluted using DBMS redefinition. But it can all be done, and that's how you'd piecemeal, without outage, move all the objects over to a new block size in a new table space. The obvious rebuttal of that is, well, rather than try canvas each example, why not just create a DBMS redefinition for every single object if that's going to work? The reason I'd guard against that is A, it's more complicated to do, but also the alter table move online facilities in 12.2 are actually pretty much lock-free. They don't take locks throughout the process, where DBMS redefinition does. There are periods during the activity where it must block access to those objects. So if you're really critical on outage behavior, then using the online table facilities in 12.2 will be slightly better than DBMS redefinition. Inherent privileges. Let's think of a simple example of how I can demonstrate why this privilege came to be in Oracle 12.2. A typical invokers rights procedure, and I'm stressing here, not definers rights, which is your default, invokers rights, are something like DBMS SQL. It's something where it's a very powerful utility in terms of the functionality it offers. And obviously we want to allow anyone to run it, but whoever runs it, they should run it with only their privileges. So it's built by someone very powerful. It's written by someone called Sys, but it's run by peasants. It's run by us. So we only get to use the privileges of the invoker ourselves. So the typical use case for an invokers rights routine is it's authored by someone with some power, and it's used by people who have very little power. So just to reiterate, invokers rights routines are often written by someone powerful because they're going to be shared out to other people, and they're run by people with minimal power. I call it like the Robin Hood concept. You know, we steal from the rich and we give to the poor. That's what most invokers rights routines are like. But what about the opposite? I might write a routine and I've only got very small privileges. You know, it's written by me. I'm a peasant. I have very little privileges. But what if I ask that to be run by someone with a lot of privileges? Is that risky? Well, it is actually a security risk, and that's why we invented the inherit privileges routine. Let's see how it can be a security risk, and this will be our last demo for today. So here's my demo. I'm going to use it called Scott. I create a table. I'm going to select on that table to public so anyone can query it. Then I'm going to write a routine that I've deliberately designed to fail, because I'm going to try hack the DBA database here. I'm going to hack our system. I know it's going to fail because it does a 1 divided by count star on an empty table. It's always going to return divide by 0. I know that for a fact, but here's how I'm going to hopefully fool the DBA into giving me unlimited access to the database. I phone the DBA. I say, look, I'm having some dramas with my routine. Every time I run it, it does divide by 0. You're a DBA, you've got more power. Can you run it for me and see if it works? He logs on as sysadmin. He looks at the source and says, yep, fine. It's just a count star, divide by 0. Yep, you're right. But this is what we call social engineering. DBAs will typically examine source for new objects. I'll say, yep, this is a routine I've never seen before. I'll go check out the source. Yep, I can see it's not particularly well coded, but it looks, safe and harmless. I run it for the guy, phone him back. Yeah, you're right. It's just a count by 0 error. I reconnect to Scott. Now look what I do. I recreate the same routine and I put line 5, grant DBA to me. Then I jump back on the phone to the DBA and say, look, I think I've made a fix. Can you just give it another go? And the DBA should at this point re-examine the source, but often they don't, or even it's maybe automated. They run it, they say, yeah, you're still getting the same error. Sorry, it's not fixed. And they send it back to the developer. And you'll pick up the phone and go, yeah, okay, Norris, thanks for trying. Not to worry, I'll keep working on it. But of course, inadvertently, guess what roles I've got now? I've just been granted all the DBA roles because someone with enormous power ran my invokers rights routine. That's what inherit privilege is about. That's how we solve it. So let's revoke DBA from Scott, given that let's get Scott back to an even keel. This is how I can do it. If I revoke inherent privileges on the user sysadmin from public, it means anyone running, when I run a routine as sysadmin that someone has provided, I will not allow my privileges to be inherited by that operator. Now when I run Scott, I get the error saying I tried to do something that Scott would actually not normally be permitted to do. And that's what this routine is designed to actually save us from. Let's go back to my notes. So there's a simple example of why it's gone. Now, really we built this for us as in inside Oracle because we write most of these invokers rights kind of routines for people to share. And so we wanted to make sure that if we ever encountered some sort of SQL injection bug or some sort of security flaw, that we would actually be able to protect ourselves from ourselves. That way we can revoke this inherent privileges from all the supplied schemas that we provide inside the database. That forces ourselves to make sure that we were not going to be caught in these security holes. Now for backward compatibility reasons, did I put it here? Yeah. For backward compatibility reasons, we actually give this privilege to everyone when they upgrade to 12.2. because it's a new privilege, we have to ensure that the behavior is as it was before. So yes, those security holes actually still are present for your code in 12.2 because we keep the backward compatibility. But obviously now that you know about this privilege, you could now explore doing it for all your invokers rights routines where appropriate. Now, it says here I've got 2 minutes left, so hopefully you'll bear with me. I might go maybe 5 minutes over time here. Hopefully you'll stay on the call. If you disappear at 9 o'clock, I'll fully understand. We don't keep a log of who logs off, so don't panic. We won't be able to attack you publicly. So the DBA career. Let's take a trip down memory lane. Who remembers these numbers? Anyone remember those numbers? These are what those numbers are. We used to get these errors when we used to have tables exceeding that many extents. If you got 121 extents in a 2K block size, you couldn't have no more. If you had 505 in an 8K block size and 249. It used to be the case in Oracle that that was the maximum number of extents you could have in a table. That was it. If you exceeded that, you had to rebuild the table from scratch. Now, no one really cares about extents anymore. Not much. You know, if we get billions of extents, we probably might have some dramas. But in 7.3, which was nearly 30 years ago now, 20 years ago, you know, we fixed it. We had unlimited extents. It was sort of semi-automatic because we still use the database dictionary to manage it. So you had to have some care. But then in 8.1, they become locally managed. They're fully automatic, bitmap extents. And from that point onwards, we've pretty much lost interest in extents. We still monitor most of us DBAs from time to time, but we certainly don't have that paranoia that we used to have back in Oracle 7 because we knew that if we ever hit that limit, we were in trouble. So we had this degree of automation, but we know how extents work. Automation for my is we sort of know the implementation. Yeah, it's being performed by the database, no longer by us, but we sort of define the rules. We define the extent sizes with LMTs, etc. That's my sort of loose definition of using the database definition of automation. But let's have another trip down memory lane. Who remembers these things? Do you remember setting these parameters in the database? You used to have to set the rollback segments parameter. You had to make sure the first one was in the system table space. All the others would be in a non-system table space. You'd set transactions per rollback segment to nominate the spread and clean up entries. There were all sorts of things you had to do to look after rollback segments. And then I think almost no one cares at all anymore about rollback segments. They almost don't even know they exist because we had automatic undo. Came along in Oracle 9, you set the undo table space, life's good. It's actually more than automation though. It's different to extents because I would challenge anyone on the call to know the result of this query before they actually ran it. It's, you know, no one knows how many undo segments they actually have currently in their undo table space because the growth and reduction of them is actually now controlled by the database. We actually allocate them as required and we remove them as well. So it's actually being decided by the database now. And this is probably closer to what I call autonomy. And that is, we don't really know the rules of the implementation of the undo table space anymore. The database has decided on what the algorithm should be. We don't even set the rules. The decisions are made by software. And that obviously leads us on to this. This is the motivation for all the questions about what about the future career? What's the autonomous database going to do to my job? Yeah, am I going to be out of a job? Now, as with all good, office hours sessions, we have to have a pie chart. This pie chart I simply stole from, I think, Computer World, which says that 72% of technical tasks in an IT department, and DBA is a part of that, are maintenance, and only 28% are innovation. So the theory behind autonomous database, like autonomous undo, is we remove the dull stuff and let you focus on the cool stuff. And you've no doubt seen that message already from various slides. So people say, I'm going to be out of a job. But think back to automatic undo. That's probably the first autonomous thing we've done in the Oracle database back in Oracle 9. Who lost their job? I would, obviously everyone on the call probably didn't because they're on the call, but I don't know of anyone that ever got told, now that undo management is so much easier and you don't have to worry about it, it's autonomous, you don't have a job anymore. All that happened was they said, great, you were looking after 10 databases, you can have 20 now because you can manage them more efficiently. I think the same is going to happen with the autonomous database stuff in terms of the DBA career. Less mundane stuff to work on isn't going to give you less work. It's going to give you more work. They're simply going to say, fine, you can have more databases to work with. You can have more technologies to look after. Yes, you used to look after the database. Guess what? You've got the app server now as well. Oh, you've got the NoSQL database as well to look after. Oh, you've got a Hadoop cluster. Yep, you better look after that as well. You're going to have just be given more and more stuff to do, and it's going to broaden your horizons. So I think that's a good thing, and also it'll actually keep your job more interesting. But I want to be real here, because people say that's perhaps too optimistic a message. And don't get me wrong, the thing that will make your DBA career flourish is if your job is about the business success. So what defines business success? It's people who do good data modeling for the system, design great systems, people who can look after end to end. Your business doesn't care if one component brings the whole system, the application down. They simply say the application is down. So if you're an IT professional that can look after multiple parts of the stack, you're obviously inherently more valuable to the business. Data security, let's face it, if you get hacked nowadays, you're out of business. That's probably the most important thing for DBA now, even today. Application tuning, that's never going to go away. For every good piece of SQL out there, there's someone out there who can write a worse version. So application tuning is always going to be present. So it's actually always been business success that defines the DBA career. It's just that sometimes we've needed multiple people to add up to the total being definition of business success. One person might have been looking after just a tiny component of it. And I will say this, if you are one of those DBAs that actually prides themselves on only looking after the maintenance stuff, and I'm not being critical of you here, some people, that's what they like to do. They like to just get up in the morning and do the same tasks each day, and they do it really well, really accurately. That's what they want to do. Then I think you could be in trouble, because the reality is that job is being automated away. So if you are focused just on the mundane, on those very basic maintenance tasks, I think, yeah, you might be in trouble, and you probably need to look at expanding your skill set. Now, it's 9:05. I do apologize for going over. I'll leave up the old blog, YouTube, and Twitter things. Please follow me on Twitter. That's where I'm probably most active. I'm coming up to my 10,000th tweet. Probably tomorrow it'll be. But those who stayed on, thank you for waiting the extra 5 minutes. As always, I didn't get through all the questions, and please publicly admonish me for that, but I'll promise I'll get to the ones I missed next month. Thank you very much for your time. There's my little skull. Fantastic. Let me stop my share so it's just me. There's my little skull from Peru. Thank you for the people in Peru who provided that to me. That's very, very cool. And we'll see you next month on DBA Office Hours. Bye for now.